Good afternoon, good evening, good morning, ladies and gentlemen. Welcome to Tutorials with Aubrey, where you get exclusive mathematics tutorial lessons. You can subscribe to our YouTube channel and ring the notification bell for more videos such as this. In today's lesson, we look at strategies we can use whenever we are solving probability questions, and we kick off this lesson with some examples. Now, um, this will be a very interesting lesson, and I encourage you to pay very much particular attention to how we are going to be working out the problem so that you will be able to solve any problem in probability. So let's dive into the first question. All right, so let's kick off this lesson with some questions. All right, 49, question 49. A person is known to hit the target in 3 out of 4 shots, whereas another person is known to hit the same target, all right, in 2 out of 3 shots. Find the probability that the target, or find the probability of the target being hit at all when both persons try. All right, so we have two people here. When one person is given 4 bullets, out of the 4 bullets, he will use 3 bullets which are going to hit target. Or in other words, the person will miss 1 shot out of the 4 shots he has. The other person, when he is given 3 shots to hit a target, he will hit 2, meaning he will also miss 1. Now they are asking us the chances that the target will be hit by both people. Now let's pay attention to vocabulary here. It's saying when both persons try to hit the target. This is one thing you should pay very much attention. When both, when both, all right? This should not be confused with when both target A and B hit the shot. So when both hits the target, we are talking about the union relationship. Okay, so this is the relationship A union B. Now here we need to be very careful, right? They're looking for the probability of A union B, right? Which is equal to 1 minus probability of not hitting. Okay, 1 minus probability of not hitting the target. Right. So if we remove the chances of not hitting the target, we remain with the chances of hitting the target. All right. So this will be our approach. Now let me write down the data in my toolbar here. So in our data here, we have probability of person A hitting the target, which is 3 out of 4. Probability of person B hitting the target, which is 2 out of 3. And all right, now let me just expand and I remove myself there. All right, so we have this information so that I can have enough space here. So probability of A, which is 3 out of 4, probability of B, which is 2 out of 3. And now we are looking for the probability of hitting, probability of A, both A or B hitting the shot, which we've said is 1 minus probability of not hitting the shot. Okay, probability of not hitting the shot. And the simple explanation here is that when the total probability of an event happening is 1, okay, that is this one, 100%. Okay, now in that 100%, when we remove the chances of not hitting the shot, what we are going to remain with are the chances of what? Of hitting the shot. Okay, and here basically we're going to say the chances of not hitting the shot is 1 minus probability of the shot not being hit by A and the shot not being hit by B. Okay, in other words, what we're getting, the shots not being hit by both A or B. Okay, of which by axioms, this is the same thing as A complement, which is A complement intersection B complement, right? Hope you get that understanding. The chances of not being hit by both of the members, A union B, okay, which is this right here, okay? So A complement intersection B complement, because which this actually makes perfect sense, because remember when you have probability of A complement, let me say, yeah, this is equals to 1 minus probability of A, of which when you make probability of A subject of the formula, take this side, you're going to have probability of A. When this goes this side, sign changes, equal to equal to 1 minus probability A complement. So this is what we are using. And some of you might be wondering, why didn't we use the formula A intersection A union B A union B is equals to probability of A plus probability of B minus probability of A intersection B. Okay, some of you might be wondering why we didn't use this formula. Well, this formula cannot work well with this example because first of all, this formula, the question has a chance of the target not being hit. Okay, it has the chance of the target not being hit, and the intersection part does not account for all the data. Remember, when you're dealing with sets, when you are trying to load your data in a Venn diagram, you started with accounting for data in the intersection, then you start subtracting from the main fields for you to get the data in the side A and the data in the side B, and so on and so forth. So this is a similar case. When we go for this formula, we are not accounting for the chances of the person missing the shots, right? So whenever you see a question similar to this one where you're not given enough data on the intersection there, we use this process, right? We account for the chance of the thing not happening. Yeah, and another thing that you should look out for is when you read our question, just go back to our question. When you read our question, a person is known to hit the target 3 out of 4 shots, whereas the other person is known to hit the target 2 out of 3 shots, right? Here already we see that there are chances of the target not being hit, which is this part, 3 out of 4. He missed one. Same here, he missed one. So there is a chance of not hitting. So we include the chance of not happening whenever we're trying to solve a problem. Then you should look at the problem. Does person A hitting the target mean person B won't hit the target? Okay. Does person B hitting the target affects person B hitting the target? No. If person A hits the target, person B can also hit the target. If person B hits the target, it will not affect the target being hit by person A. So this question is an independent type of question. And remember, when we're dealing with independent questions, probability of A intersection B. When you're dealing with independent questions, probability of A intersection equals to probability of B A times probability of B. So here we proceed. So if you used that formula, you get a problem there. So here, let's proceed. So this will be equal to 1 minus probability of A complement times probability of B complement. So that will be probability of A union B. Okay, which is 1 minus, what is A complement? A complement is 1 minus probability of A, and B complement, this is 1 minus probability of B. Okay, when we proceed, okay, this will be equal to, this will be equals to 1 minus, in brackets, in brackets, 1 minus probability of A, which is 3 over 2, 3 over 4, so 3 over 4 times 1 minus 2 over 3, which is 1 multiplied by, this will be 1 over 4, this is times 1 over 3, which will be equals to 1 minus 1 over 12, which is 11 over 12. And when we convert this to percentage, is about 91.67%, which makes perfect sense because remember, person A only misses 3 out of the 4 shots, which is a higher chance of hitting it, and person B only misses 1 shot out of the 3 shots, which is also a higher chance of hitting the target, right? So this was the approach for the first question. So let's dive into the next question. Question 51. 2 persons A and B appear in an interview for 2 vacancies, right? There are 2 vacancies for the same post. The possibilities of A's selection is 1/7, and the possibilities of B's selection is 1/5. What is the probability both of them will be selected? Okay? Remember the vocabulary we talked about? Both of them will be selected. So whenever you see both of them will be selected, or both A or B being selected, then we are talking about union, right? But if they said, what is the probability that both A and B will be selected, then we are talking about intersection. So you should take note of that. So it is the similar procedure as the previous one there. So here we just need to find, we are finding probability of A union B, right? Which is which will be 1 minus probability of not being selected, right? So that is the same approach as the previous question. Probability of both of them will be selected is equals to 1 minus the chances of them not being selected, which we've previously discussed about. Question 51, 2. none of them will be selected. So none of them will be selected. None of them is actually probability of A, B complement, right? Probability of A, B complement, which is just 1 minus probability of A union B. So that is the approach for the second one, probability of A union B complement, which is just 1 minus probability of A union B. And question 51 is done. Okay, we go to question 52.